Okay, so in this unit, we're going to be simplifying rational expressions, which are any fractions that have variables in both the numerator and or the denominator. So, for example, like x plus y over x would be an example of a rational expression. And we're going to learn how to simplify them, how to state excluded values, multiply, and divide them. So again, a rational expression is in its simplest form when its numerator and denominator have no common factors. So in order to simplify this, you need to factor both the numerator and the denominator. Okay? Now remember, you cannot just cancel out the x squared here and here. Okay, that's very, very bad because these are terms, and you can only cancel factors, not terms. Okay, so we're going to undo that. And what you can do instead is you can factor the numerator and the denominator. So go take a few moments to go ahead and do that. Okay, so if you did this correctly, this is what you would have gotten for the top and for the bottom. And then you notice how we have x plus 6 on both the top, x plus 2 on both the top and the bottom. So we can go ahead and cancel those out, and that can leave you with the final answer of x minus 6 over x minus 2. And this is essentially what the gist of the whole lesson is, which is to factor and cancel. Factor and cancel. Before we move any further along this one, we do need to talk about how to restrict the domain. And you can learn a lot more about this in pre-calculus next year, but we do want to expose you to some of it here in honors algebra 2. And remember that domain means all possible values of x. So the main restriction is you can never divide by 0. You can never have 0 in the denominator. Okay, so in the case of this one that we just did, I'm going to go ahead and rewrite the factored form again for you right here. X plus 2 over x minus 2 and x plus 2. So restrictions are what x cannot equal. And it's anything that would make the denominator equal to 0. So in the case of the excluded value, x cannot equal 2 or x cannot equal negative 2. And we say that right here because if you put 2 in for x right here, you would get 0. And 0 times this would give you 0. And you'd be dividing the whole expression by 0, and that's not good at all. Same thing when you put negative 2 in for x. You put that here, you get 0 for this. And then that makes the whole denominator equal to 0. And that's why we call those domain restrictions excluded value, which means that the final answer for this expression, what we said was x minus 6 over x minus 2, applies so long as x does not equal 2 or negative 2. And you have to do the excluded value before you cancel anything out. So, or you can make sure you take that into account, anything you canceled out. Okay? All right, so let's go and practice this a few times. Okay? Go ahead and simplify both numbers 1 and 2 and state the excluded values for these. Go ahead and pause the video and work on these. So if you did everything correctly, this is what you would have gotten along the process. Okay, so for the first one, notice that the x plus 1 cancel right off the bat. And then we can also state the excluded values as being x cannot equal negative 1 or negative 3. Okay. The second one, you need to factor the denominator. And then remember, since the x plus 4 cancel and you have nothing left on top, you got to put a 1 up here as a placeholder. And that gives you 1 over x minus 4. And then the excluded values are x cannot equal 4 or negative 4 based on these two denominators. Okay? All right, so let's move on here to the next one. Okay. So again, pause the video and see if you can simplify both 3 and 4 and state any excluded values. Okay, so if you did this correctly, you will notice that number 3 is already simplified. There's nothing that cancels. However, you still need to state that the excluded values on x cannot equal 0 due to the presence of this x right here, and x cannot equal -2 due to the presence of this x over here. Okay, now for number 4, once again, you have to factor and then cancel. So once you factored everything, you'll notice that the x minus 3 cancel. Oops. Okay, you gotta get the point. And you're left with x plus 1 over x plus 2. But the excluded values include both the 3 that canceled and both the -2 that's left over right here. Okay? All right. So now, let's talk about how you can multiply and divide these things. Okay, now if you recall from how you can multiply a fraction, if I do something like 3 over 4 times 6 over 9, you can always cross reduce. So we could reduce, for example, the 3 and the 9 right here, and say that's 1 and 3. And then you can cross reduce this and this by dividing both of these by 2 to say that's 2 and that's 3. And then you cancel the 3 up and down right here, leaving you with 1/2. Okay, so in a problem like this one here, I would first cross reduce any coefficient. So I would cross reduce the 8 and the 4. So this becomes 2, and then this is the 1. And then I would also then cancel out these 2's over here as well. And then I would multiply straight across, giving you 7x to the 7th, y to the 4th, over x, y to the 4th. And then you can simplify based on your understanding of how to reduce your exponent. And that becomes 7x to the 6th power. Okay, excluded values here is that x cannot equal 0, and y also cannot equal 0 either, because these are both standalone terms. Okay, it's not x plus or x minus, so then therefore we say x cannot equal 0, or y cannot equal 0. Okay, so moving on, how we can multiply. Okay, we can do what we talked about earlier, where you need to factor. Okay, so what you have to do is we're going to factor everything in number 1. Okay, and the one thing that's bothering me about the third part of number 1 is this part right here. Okay, so I'm going to rewrite it so that it is -3x squared plus 3x to make it easier to work with. Okay, then I'm going to factor. Okay, from this part right here, you have to remember to factor out the greatest common factor, which in this case would be -3x. Okay, so I'm going to factor out a -3x. And we get x minus 1. Okay, over, in this bottom part, factor to x plus 5, x minus 1. Okay, upper right also factors to and the bottom is 3x. Okay. And now we can cancel. Okay, so first, we're going to use the highlighting function actually. I'm going to cross off the x plus 5. Okay, I can also cross off just the 3x, as well as the x minus 1. And that can leave you with the final answer of, don't forget that negative in front of the 3x, negative quantity of x minus 4. Okay? Alright, so the excluded values are anytime x was in the denominator. So x cannot equal -5, 1, or 0. Okay, this is -5 from this part. Can't equal 1 because of this. 1 minus 1 gives you 0. And also this can't equal 0 because 3 times 0 is 0. And that would give you 0 in the denominator. Okay, so that right here would be your final answer. Okay. Alright, So go ahead and take a moment to try to practice number 2 with your factoring, and don't forget how to factor cube. You might find it helpful to put this over 1. Okay, so take a moment to practice the factoring. Okay, so if you factored x cubed minus 27 properly, you've gotten x minus 3 times x squared plus 3x plus 9. And at this point, we can cross cancel this and this, leaving us with a final answer of x plus 2 over x minus 3. X cannot equal 3. This part right here is not factorable, and when you do the quadratic formula to see when it equals 0, you'll notice it's imaginary, but we do not need to include imaginary number as part of excluded values, so it is perfectly fine to stop at this point and say that this is your final answer. Okay, so go ahead and try. Let's say we can focus on number 8 and number 9. Sorry, number 3 and number 4. We're not going to worry about number 5. That's more of the factoring cube part. Okay, so go ahead and practice 3 and 4. Pause the video, and then check your work and when you're ready to resume. Okay, so here's the answer. A couple of things I want you guys to note on these is that on this one right here, this number 4, I factored out 2x, and I factored the bottom. Then when you cancel, these cancel, and then the 2 cancel as well. And then the x and x squared partly cancel, where this x cancels out one of these x's. So you'll have this x left over, as well as this x plus 5 and x plus 3. Okay, included values would be 5, -5, and also can't equal 0 due to this standalone x right here. Okay, all right, so let's go ahead and finish up with division. So the thing about dividing fractions is that you may recall from your earlier, middle school math classes or elementary school, that when you divide fractions, you change it to multiplication and you flip the second one, and then do the exact same thing. So we're going to do the same thing with this one. We're going to flip the second one, and then you go ahead and factor and cancel. Okay, so go ahead and pause the video and factor and cancel everything. Okay, so this is what I got. When you do the excluded value, you have to look at the denominators right here. So x cannot equal 5 from this one, x cannot equal 0 from this one, and x cannot equal 6 from this one. However, you have to also check the numerator up here because it was originally in the denominator over here. But we've already included both 5 and 6 based on these parts right here. But you have to always check here and here, as well as anything that was originally in the denominator. And that's the point that we were trying to make right here. Okay? Alright, so let's go ahead and try these examples. Just going to just do number 3 and number 5, and I think we'll call it a day. So I'm going to circle those. And this one. Don't reach my spot, number 4. Okay, so pause the video, and let's factor and cancel. And don't forget to change it to multiplication. Okay, so go ahead and check your work here. And notice that I put these over 1 right here. And I flipped it to give you 1 over all of this. Notice then that the 3x plus 5 cancel once I factor this part. And then I have 2x minus 3 for the top and 4x cubed on the bottom. And because of this x right here, as well as this one, x cannot equal 0. And because of this, if it helps you to see it, we want to say 3x plus 5 cannot equal 0. 3x cannot equal -5. Therefore, x cannot equal -5/3, which is how I got that excluded value over here. Okay? And I did the same thing for number 5. Okay? Alright, So I think that about covers everything, and hopefully that makes sense as you work on the homework. Okay? All right, so have a good one.